It's interesting to observe when thinking about the vastness of the cosmos that the universe seems oddly empty, even within our vast solar system. Even if reduced to the size of a quarter, the closest star would still be around 2 soccer fields away. We get a taste of the enormity of cosmic immensity from this magnificence, which spans just inside our Milky Way galaxy, one of billions in the observable cosmos. The newest finding made by the James Webb Space Telescope adds a new level of a remarkable discovery by the James Webb Space Telescope points to the beginning of everything and calls into question the fundamentals of our knowledge. Scientists and astronomers have been fascinated by this discovery, which raises the possibility of a massive catastrophe that could alter the universe as we know it today. This discovery is extremely significant and raises questions regarding the fundamentals of our cosmic existence. It begs the question, may everything we know end as a result of this discovery? Is the cosmos about to undergo a radical change that we cannot yet comprehend? Come along as we examine the most recent discovery from the James Webb Space Telescope and consider how it might change how we perceive the universe. We start by looking at the observable universe, which serves as our window into the enormous cosmos. Everything that our telescopes and space missions can detect, measure, and investigate is included in the observable universe. We can see a collection of stars, galaxies, and other celestial things, but they only make up a small portion of the cosmos, a small piece of a vast cosmic jigsaw that people try to understand and explore. The general size and shape of the universe are still unknown despite our progress. It is estimated that the observable universe has a diameter of about 93 billion light-years. The distance that light may travel in an Earth year is one of the many elements that contribute to this startling number. The observable universe is thought to be 13.8 billion light-years in all directions from Earth and has a diameter of about 93 billion light-years, based on the universe's estimated age of 13.8 billion years since the Big Bang. But according to Hubble's law, the observable cosmos has been expanding since the Big Bang because space has been expanding. According to current estimations, objects that were 13.8 billion light-years ago and are now about 46 billion light-years away are thought to have emitted light. According to this expansion, the observable universe is more than 46 billion light-years away from Earth in all directions. The cosmos is growing and accelerating as a result of the cosmic expansion that was started by a strong explosion billions of years ago. This acceleration appears to be caused by enigmatic forces, such as the enigmatic dark energy, which is pushing the boundaries of the cosmos farther apart. Amazing formations like stars, galaxies, and planets, including our own Earth, were created as a result of gravitational forces drawing particles together as the universe expanded. Technological developments have enabled mankind to continuously explore more of the cosmos, despite the universe's vastness. Distant stars and galaxies may now be seen thanks to specialized telescopes like the Hubble Space Telescope and the James Webb Space Telescope, which has increased public access to these wonders. Excitement to our understanding of the universe as we continue our investigation, raising more concerns about the nature of our existence and the possibility of dramatic cosmic occurrences. Why we are unable to witness the entire universe may be of interest to you. This restriction is due to a number of factors. Even though light is the universe's fastest object, intergalactic travel nevertheless takes time. As a result, we are effectively looking into the past when we examine far-off objects. We see galaxies that are millions, if not billions, of light-years distant, and the more away an object is, the longer its light has traveled to reach us. This creates a kind of cosmic time capsule that reveals the history of our universe. The expansion of the universe is another important element at work. Imagine an inflated balloon with dots covering its surface. The dots separate as the balloon gets bigger. Likewise, as the fabric of space grows, galaxies drift away. Redshift is a phenomena caused by this expansion, in which wavelengths of light emitted by far-off objects are stretched toward longer, reddish tones. As the universe continues to expand, some celestial bodies eventually pass beyond the cosmic horizon, where their light is too far away for humans to see. It's hardly surprising that we haven't yet viewed the entire universe given these two important factors, the expansion of the cosmos and the travel period of light. The basic characteristics of the universe continue to limit human perception even with the most sophisticated telescopes and technologies. Let's examine these ideas in more detail. Measured in light years, which represent the distance light travels in a year, the universe's immensity is astounding. The Milky Way, our galaxy, is around 100,000 light-years in length. Proxima Centauri, the star nearest to our Sun, is around 4.24 light-years away, even within our galaxy. We can get a glimpse of the early history of the universe by looking into space and seeing galaxies that are billions or millions of light-years away. People from a variety of areas have been fascinated by the enigma surrounding the edge of the universe. Although definitive answers are still difficult, three important possibilities have been proposed. According to the first, the universe is endless, huge, and growing in all directions without any apparent end. The second, which is compared to a vast spherical or curved space, proposes a finite universe without a distinct edge. As in the case of circumnavigating the Earth, one would eventually return to the beginning point after traveling eternally in any direction. The third theory, known as the multiverse concept, presents the notion that our universe is one of many, each with its own unique set of physical laws and characteristics. These universes could function separately or together to create a huge, complex multiverse. Investigating these hypotheses piques curiosity in both philosophy and science. The idea of an infinite universe contradicts how we view space and its immensity. On the other hand, the possibility of cyclical patterns within the fabric of space is suggested by a finite cosmos without a boundary, which calls into question our ideas of limits and continuity. With its parallel worlds, the multiverse theory raises questions that we can't yet answer and suggests that there are worlds that are very different from our own. It's important to remember that these ideas are still theoretical and elusive and need more research. There are several obstacles to overcome while exploring the edge of the universe, which makes it challenging to confirm or refute current hypotheses with certainty. Uncovering the mysteries surrounding the universe's boundaries is made more difficult by the size of cosmic space and the limitations of our technology and observational tools. The James Webb Space Telescope, on the other hand, stands out as a ray of hope amid this cosmic ambiguity, offering to provide insight into the mysterious origins of our universe. The JWST is a revolutionary instrument that provides unmatched precision in observing the cosmos. This special tool could reveal the mysterious past of our cosmos and offer insights that were previously unthinkable. The JWST, a technological marvel, has recently made groundbreaking discoveries, especially in the study of the edge of the cosmos. The discovery of 6 huge galaxies that date from 500 million to 700 million years after the Big Bang is one of the astounding discoveries. This study, which was published in the journal Nature, casts doubt on long-held beliefs regarding the formation and evolution of galaxies in the early universe. These old galaxies are surprisingly large in diameter compared to their age, which defies expectations and changes the story of cosmic evolution. The discovery of these enormous cosmic objects shocked scientists, who had initially expected to see little, nascent galaxies. These elderly galaxies are remarkably mature, on par with the Milky Way galaxy, which is 13 billion years old. Some galaxies may have a stellar mass up to 100 billion times that of our Sun, and the stars within these galactic giants have an unfathomable total mass. Because the JWST uses infrared light, which is invisible to the human eye, it has an unmatched ability to observe the mysteries of the cosmos. By detecting feeble emissions from old stars and galaxies, the telescope can uncover cosmic leftovers that have persisted for billions of years. The JWST acts as a time machine, transporting our view back through the ages and offering priceless insights into the universe some 13.5 billion years ago. Our knowledge of cosmic evolution has been completely transformed by the recent discovery of massive galaxies known as universe breakers. These surprising results cast doubt on long-held theories and the widely accepted notion that galaxies began as tiny objects and underwent progressive evolution. Beyond all expectations, the James Webb Space Telescope has been instrumental in solving the riddles of these huge galaxies through its spectroscopic techniques and high-resolution images. A further layer of mystery to the cosmic fabric is the potential existence of supermassive black holes beneath these galaxies. The known mass of stars in the universe may now be up to a startling 100 times greater than earlier predictions, even when only 25% of the data is taken into account. With every new finding adding to our cosmic map and providing a more thorough picture of the universe's history and evolution, this discovery forces a fundamental re-evaluation of our knowledge of cosmic mass and structure. Beyond their size, these gigantic galaxies have profound consequences that call into question basic theories and cause us to re-evaluate how we understand the evolution of the cosmos. With its state-of-the-art technology, the James Webb Space Telescope has been instrumental in pushing our understanding of the universe to previously unheard-of levels. The identification of the oldest and most distant galaxies ever observed is one of the JWST's amazing discoveries. These galaxies, which survived only 400 million years after the massive event known as the Big Bang, take us back to a time when the universe was only a small portion of its current age. The fact that the light from these galaxies started its trip more than 13.4 billion years ago and eventually reached our detection through the JWST lens only heightens the curiosity. Similar to the Hubble Space Telescope's initial observations, the JWST's first images showed a large number of potential galaxies. By means of advanced spectroscopic analyses, astronomers verified 4 of these celestial occurrences, making it possible to precisely estimate their distances from us and conduct a thorough analysis of their physical characteristics. Redshift is a concept used to calculate the distance between galaxies. The Doppler effect is the stretching and shifting of light waves from astronomical objects toward longer wavelengths as they appear to move away from our perspective owing to the expanding universe. Although redshift can be estimated from pictures using different filters, spectroscopy is the preferred method for getting accurate readings by breaking down the object's light into its individual wavelengths. By concentrating on 4 galaxies with redshifts larger than 10, the JWST's findings highlight how far away they are from us. For comparison, galaxies with redshifts of 10.38 and 11.58 had previously been found by the Hubble Space Telescope. However, 2 far more distant galaxies with redshifts of 13.10 and 12.63 were discovered by the JWST. A redshift of 13.2 provides an intriguing window into the past of the cosmos by accurately implying a time period of 13.5 billion years ago. The James Webb Space Telescope's ambitious goals are demonstrated by its sophisticated Deep Extragalactic Survey, or JADES. JADES, a global partnership of over 80 astronomers and scientists from 10 different countries, was conceived in 2015 by a group of instrument teams. Their goal is to start a vast exploration of the early universe in order to solve long-standing riddles.